Cool. So let's switch gears now. Let's see if I can clean that annotation. Okay, good. So I want to switch gears and talk about the second topic, which is normals. We're going to need normals of surfaces to actually compute the lighting using foam shader. This means that we're going to need to pass per vertex a normal. And so let me, again, I think I will try to draw again. So for example, for the sphere, right, imagine a sphere like a low resolution sphere like this. It's going to be super challenging. So imagine like a sphere that has very like low resolution, and I have this. These are my kind of my vertices. So for each of these vertices, I'm going to have to send a normal. Right, and a normal here is like a normal of the surface of this face, for example, is this vector pointing up from the surface, or orthogonal vector here. Okay. And to calculate lighting, we're going to actually need one of these per vertex. So we're going to actually need one of these here, one of this here, one of this here, right? One of this here, so on and so forth. So we're going to need all of them. Okay. So in this case, we would pass for each vertex of the sphere here. You're gonna pass one normal. Okay, so this is our n. See that I hope you can visualize it. For the sphere, the normal of this vertex is actually the vertex, the distance from the center of the sphere, or the vector pointing from the center of the sphere to here. So for each of the vertex, the normal is actually the vector again from the center to the vertex. So it's very simple to compute normals for a sphere. So a normal here for a given vertex, let's say I, is the vertex position minus 0, which is the center. So it's actually equals to V. So it's funny because for the sphere, this is a special case. For the sphere, their normal is the same as the vertex. For the cube, it's slightly different, right? For the cube, this rule doesn't apply, because if you have a cube, the normal of this vertex for the top face is this vector. For the same vector, but looking from the perspective of the left face, this is the normal. From the front face, this vector actually has this is a kind of like this. This is the normal. in this case, for the top face, this vertex has a normal equals to 0, 1, 0. And for the left face, the same vertex has minus 1, 0, 0. And the same vertex, but for the front face, you get 0, 0, 1. So for the cube, I think it's easier to just hard code the normals. For the sphere, you can compute them just by giving the vertex. Or in a more general case, remember all these geometries that are made of triangles. For this assignment, you can deal with normals just by hard coding them, and because we're gonna have, most of you are gonna have only spheres and cubes in your world. You're not dealing with any complex like 3D model that is kind of comes from an artist or something. But for these geometries, you can compute this way. Or remember, you can also use the cross product to compute for a given triangle. You can use the cross product to compute the normal for each of these vertex. It's another way you could do. For this lab, I'm gonna work only on the sphere, so I'm gonna actually just implement this case. Okay. Later, you're gonna need to do the same for the normals. Any questions about this idea? Okay. Okay, cool. It's good that you saw that in class. So let me see. So what I want to do now is yeah, I'm gonna actually pass the normal. So let me comment this. This is the X, Y, and Z. This is RGB. This is UV. You're gonna need an extra component here, which is NX, NY, NY, and NZ. And I'm gonna duplicate the points, because remember that to keep it in generic, whenever you're gonna do the cube, you're gonna have different numbers than the actual vertex position here. So I could kind of reuse in my shader, I could reuse my attributes and stuff, but I want to actually make a new attribute and give a new set of numbers, even though they are the same values. So I'm gonna copy an extra line here for each of these vertices, sorry. So this is a position. This is a color. This is I think UV. And now you're gonna make a new attribute called normal. Okay. For the cube, we're gonna need to add 3 more values here as well. For each line, we can do that later, but you're gonna have to, for each line, add 3 more values, which have to be like these values from here. Okay, So let's go now to our shader. Where is it? We are gonna have another attribute, vector 3, a normal. Okay. And we are gonna need this normal in the fragment shader because you're gonna compute the light in the fragment shader, not in the vertex shader. Okay. So I wanna have here and also a varying variable, v normal. And I want to pass the normal like this. Okay. And I want to access the normal in my fragment shader. So yeah, that's it. Okay, this is done. Later we're gonna actually use the normal, but now let's actually, just for debugging purposes, let's comment this out. I think this is useful, and set the normal to be the color. Vector 4, sorry, v normal 1. So then if you see the colors on the sphere, then we are passing the normals correctly. Okay, I like this. Okay, so next step is to set up our buffer. We have to have similar lines here for the attributes, right? We're gonna have the attribute now normal. Here, and here is a normal. A normal has size 3 components. Now the size of our vertex increased from 8 to 8, 9, 11, right? 3 more, 8, 9, 10, 11, 11, 11. And I'm going to start reading from the 8th, 9, and 10. So these are the values of the normal. Starts at 0, right? So this is 8th, and this is a normal. Okay. I think that's it. I think that's it to pass the normals. Let's see. No, there's a bug. Okay, bug in the shader. Attribute, oh, I'm missing, there's a typo in there. Invalid, okay. Also, we have to divide by 11 in our draw function. Nice. I think it worked. Let's try to visualize this. What's going on in here? See that the top of the sphere is greenish, right? And green is the 0, 1, 0. So this fragment here should be exactly green, the one on top. Let's see if I can go up there. Oh, I can't tilt my camera. But so this one here is fully black. The center one here, because this is, okay, let me refresh. this is looking at me. So this is 0, 0, -1, I think. This is 0, 1, 0, which is green. This is 1, 0, 0, which is red. This is also negative, so it's black. This is -1, 0, 0, so it's black. This whole area here is going to be black because it gets negative values of the normals, and it clamps to 0. So colors get colors in the fragment shader, they get clamped to 0. So that's why we see black. But this area should be right, and this is blue because this is the 0, 1, 0. This is the Z positive. Okay, 0, 0, 1. So it looks right actually. It looks that this makes sense. I just don't like that. I think our triangles might be. Yeah, I have to make sure this triangles are not inverted. I think, yeah, they should. Maybe there is an inversion here, but I can fix that. Fine. Because you're seeing the edges and see like these jumps of color here. They should be a smooth transition. Yeah, but overall is actually looking good. I mean, at least the normals are fine. Normals are correct. Okay, that's good. That's done for. This is it for normals. My third. So actually, any questions about this?